Hi there. Let's take a few minutes and talk about question 1516. This continues from the previous question where we were looking at an explanatory variable, the number of stumps left behind by beavers as they cut down trees. The response variable is y, that is the number of beetle larva clusters that we see on those stumps. So first thing, what we are looking at here, these are the residuals for the 23 observations, but they've been standardized. So for each residual, we have subtracted the mean and divided by the standard deviation. So remember what standardizing means. We've made z-scores. So this first residual is negative 1.99. So that's 1.99 standard deviations below the mean. The second residual is 1.2 standard deviations above the mean. So a little bit of a review question here. Find the mean and the standard deviation of the z-scores here, these standardized residuals. So something to think about, you can always find means and standard deviations from lists on your calculator pretty easily. I'm going to turn off this equation here and go back to the home screen. So if you press second stat, the residuals were given to us in the book. You didn't have to run the regression and use the resid list. So I'm just going to take the mean of my residuals. I put them into list 3. Second stat, once again, I can find the standard deviation of list 3. So these values shouldn't be much of a surprise. These are z-scores. So a set of z-scores should have a mean of 0 and a standard deviation of 1. The difference here is just rounding error. So if you look at how I wrote about this, so the mean is approximately 0.0017, nearly 0. The standard deviation is approximately 1.0137, again approximately 1. Not a surprise because standardized or z-scores should indeed have a mean of 0 and a standard deviation of 1. So good review. Time to look then at the second part of the question. You were asked to make a stem plot of these standardized residuals. I said to just make a histogram on your calculator, and are there any deviations from normality? And in particular, is this residual unusual in any way? The negative 1.99 is surprisingly large, I suppose, or is it surprisingly large in the negative direction if you have 23 observations from a normal distribution? The answer is no, it's not particularly surprising. Let's look at the histogram. So to set up the histogram, we want to take a look at a histogram of list 3. That's where I've put these residual z-scores. So a good window will be from negative 2.25 to 1.75. That'll allow us to see all of the residuals. I'll use a scale of 0.25. That'll give us the width of our bars. So the histogram demonstrates maybe just a little bit of skewness to the left. There aren't any outliers. I don't see any serious deviations from normality. So again, the way that I wrote about this, the plot doesn't have any outliers or serious skewness, maybe a little skewness to the left, but it's reasonable to believe that for every x value, the response might really be distributed normally. That's one of the requirements for inference. But then dealing with the residual of negative 1.99, something to think about from chapter 2 is the 68, 95, 99.7 rule. 95% of the observations, if these are normally distributed data, should be within 2 standard deviations of the mean. So a z-score of negative 1.99 is not unusual. Remember what this rule means. For normally distributed data, 68% will be within 1 standard deviation of the mean, 95% of observations will be within 2 standard deviations of the mean, and 99.7% will be within 3 standard deviations of the mean. Of course, that leaves just a little bit of room for outliers. So last part of the question then. In part C, plot the standardized residuals against the explanatory variable. That just says make the residual plot. Are there any special patterns? And the answer is no, there isn't. There aren't any patterns. So back to a scatter plot. I'm going to use list 1. Those are my explanatory values, and list 3 are my residuals. So I could see all my explanatory values from 0 to 6, and I could see all my residuals from negative 2.25 to 1.75. So there's my scatter plot. So there are no patterns here. For every value of x, there are some residuals that are both positive and negative, so I don't see anything suspicious there. The way that I wrote about this then, the residual plot doesn't demonstrate any patterns, so it may be that the standard deviation of the response is the same for all values of x.